everyone and welcome back to my channel. Today I am going to show you how to solve some of the challenges from the University of Toronto CTF 2024. This CTF ran from January 13th to January 14th, 2024. So let's start. The first challenge I am going to solve is called Baby's First IoT Flag 1. All the details required for this challenge are also provided in Baby's First IoT Introduction. The description is the following collections of challenges utilize the instructions provided below. For each flag there will be a challenge to submit it. The flag format will not be the standard flag format and the root IP is this. Part 1 is here is an FCC ID. This is the ID. What is the frequency in megahertz for channel 6 for that device? Submit the answer to the provided port. So I'm going to copy the FCC ID, going to paste that ID and then search up channel 6 frequency. Now as you can see, these are all the write-ups for the same challenge, but when I solved this challenge these were not there and this was the first link that came on top. When I click that, I will go to RF exposure info because that will have the info that we need. When I open the PDF, RF exposure report, then I will scroll down and we can see output power, and for channel 6 the channel frequency is 2437 in megahertz. And now at the time that I'm recording this video, they have already turned off the port connections. But if I were to connect to this IP at this port and enter 2437, it will still not give me the flag. So I was stuck on this for a while, but then I checked the hint and it said if there is an issue with submitting an answer with a challenge, try including new lines and null characters. For example, this. So I copied that command and I replaced answer with 2437 and the port with 3895 and it gave us the flag. Let's move on to the next challenge. The next challenge I am going to solve is called Baby's First Pyjail. The description is Windex told me that jails should be sourceless, so no source for you. At this time while I am recording the video, the connections are already down. So I got the source code from their GitHub and then I ran it on my own. So let's solve. So we're going to act like this connection is the actual challenge connection. It's the same file that the challenge was running. So I'm going to do import OS and it says try harder. I'm going to try exec eval, none of them work. I'm going to try to open and open is also blocked. So the next thing I'm going to try is called breakpoint, which worked. So now I'm going to do import os.system ls. os.system runs system commands. And as you can see, we see child.py and flag.txt. So I'm going to cat flag.txt. And as you can see, we got our flag. Let's move on to the next challenge. The next challenge I am going to solve is in the forensics category called Secret Message 1. The description is we swiped a top secret file from the vaults of a very secret organization, but all the juicy details are craftily concealed. Can you help me uncover them? We are provided with a file called secret.pdf. I already have that file installed, so I'm going to open it. And as you can see, it's a transcript, a very private conversation, and it's a confidential document. So if I go here, because I can see some covered up things, it says just make sure the flag is well protected. We don't want a repeat of last time. Definitely not. The flag is securely embedded. So the flag is right here. But I don't know why Windows doesn't let me highlight it or copy it or do anything. So What I did is that I went on Linux and I opened it using XDG. I highlighted and you can see the flag and I can copy it. And I open flag.txt and I paste it. I can remove the quotes and that's our flag. Let's move on to the next challenge. The next challenge I am going to solve is in the forensics category called Hourglass. The description is no EDR agent once again. We imaged this workstation for you to find the evil. We're given a download link. When I download that, I have two files, a hash and a VM, which is in the .ova file format, which is basically a VM. So I go to VirtualBox and I open that VM and it's a Windows 10 VM. I'm going to start it. As you can see, we are provided with the welcome screen. The user's name is analyst. And we're provided with two files, flag.txt and readme. The flag.txt is just a fake flag. The readme says womp womp. Would you look at that? Once again, the security engineering team forgot to install an EDR agent. We imaged this machine to pass it on to the forensics team. Your task is to find indicators of compromises and possibly the flags. Good luck, have fun. So, I'm going to go to terminal. And just look around for stuff. And these are just the two normal files that I just read. And so when I was doing this CTF, I couldn't find anything really helpful. So I decided to open these files again. I went to Notepad. And now what caught my attention was the recents. Readme flag.txt was the ones that I opened. And then there's this settings, which is the most recent one that the challenge author used. And it looks like it's some kind of encryption. So I'm going to copy this and then go to CyberChef. So that file, I'm going to paste it and magic, and as you can see, it gives us the flag. The next challenge I am going to solve is in the binary exploitation category called Basic-Overflow. The description is this challenge is simple. It just gets input, stores it to a buffer. It calls gets to read input, store the read bytes to a buffer, then exit. What is gets, you ask? Well, it's time you read the manual, no? Cryptic message from the author. There are times when you tell them something but they don't reply. In those cases, you must try again. Don't just shoot one shot. Sometimes they're just not ready yet. So we need to see what gets function is, and we can use the man command in Linux. And the description is never use this function. It reads a line from standard input into the buffer and it reads all the way till a terminating new line. So how is this going to help us? Let me tell you. Let's say we take in 8 bytes using gets, a variable, let's say buff, which is 8 bytes. And so if we give input a and then a new line, the input stored in buff is these two characters. However, if I give 12 of them like that, you can see that we give them 12 characters and then a new line, and it still works. And buff takes 8 characters, but we're giving it 10, causing a buffer overflow. because it can only hold 8 bytes, not 10. So, this is what we are going to use to exploit this program. The file is called Basic-Overflow. I'm going to make it executable and run it. And as you can see, it takes an input, I give a and it just exits. So I'm going to use Ghidra to decompile this code. And we have two functions, main and shell. Main function takes input using gets for 64 bytes or characters. Then there's another function called shell, which is not called, but that function basically gives us the shell. So we need to call this function somehow. Now we can use the buffer overflow from the main function to call the shell function. This is a simple technique called return to win. So to do that, we need to first know the address of the shell function, and we need to also know how far the stack pointer is from this variable, so that we can give it the address of the shell function so that it calls the function for us. So what I'm going to do, I'm going to go to GDB and I'm using GDB Peda. I'm going to do pattern create hex 150. So right now I'm finding the offset. Offset is basically how far the pointer is from this, the instruction pointer or stack pointer from this variable. So I'm going to copy the pattern, run it, paste, and we can see we get a zigzag, which is a segmentation fault. That means we caused a buffer overflow. Now I'm going to do pattern search, and we can see it says RSP offset 72 registers point to pattern buffer, and it also says that RBP contains our pattern and the offset is 64. Sometimes it can be confusing on which one to use. So if 64 for example doesn't work, then we can use 72. So I'm going to open the exploit code and I am going to import pawn tools, which is what we're going to be using for this challenge, and for every single binary exploitation challenge you have to use pawn tools. Now this is quite complicated, but it's basically necessary for every single binary exploitation challenge. And then IO is elf.process. So IO is basically running this process. So I can send data and read data through my IO variable. So for example, first we need to know the address of the shell function. So to do that, first we'll use checksec. And you can see pi is disabled. That's good for us because the address of this function is going to be the same every time I run this binary, because there's no pi. If pi was enabled, then it would be hard for us to find the shell function, because every time the address of that function would change. We also have no canary, that means we can easily exploit our buffer overflow. So our shell function address is that. Our offset was 72. So we just need to do random bytes till 72 and then our payload. So payload is 8 bytes because pawn tools supports bytes. Now sendLine is used to send data, and then I'm going to do payload pack address. So pack basically formats the address so that it can be used by the binary and the instruction pointer and stack pointer. IO.interactive basically makes it interactive, so now I can send data myself instead of using sendLine to send it. Now I'm going to run this, and as you can see we get our shell. Then I can just cat flag.txt, and this was the flag it would give me. Let's move on to the next challenge. The next challenge I am going to solve is called Baby-Shellcode. The description is this challenge is a test to see if you know how to write programs that machines can understand. Oh, you know how to code? Write some code into this program and the program will run it for you. What programming language, you ask? Well, I said it's the language that machines can understand. So that language is going to be assembly. And we're given with a download file and a remote connection. So let me go to Linux and you can see this is the file. When I run it and I just input A, it says illegal instruction because A is not a valid instruction in assembly. So we need to send it assembly code that somehow gives us shell. Well, that is easy thanks to Pawn Tools. So I'm going to import Pawn Tools, set the elf variable. Now we're not going to use elf for this challenge specifically, but it's a good habit to define it because it has most of the stuff that we need for Pawn challenges, like the address of most functions like we used in Basic-Overflow. Then define our IO, which is our elf process. It's like input output. We use it for input output, that's why its name is IO. So we can send data and we can receive data easily. Now we need our actual shell code that we need to send it. So our shell code is, now this is very easy because of Pawn Tools. All I have to do is that shellcraft.sh, sh is the shell that we're calling, and asm is the assembly function. This is our shell code right here. All we have to do is send this and it will give us a shell. It's just that easy. So I send shellcode using send line. And then of course we have to make it interactive so that we can interact with the shell. Now I'm going to run this. ls. And as you can see, we get our flag. Now I did this on my computer locally because again the remote connection was down. But if I was going to use a remote connection, I would copy this. I would go here and change this to remote, which is a remote connection, not a process locally, but connecting to another computer or remote connection, and save. And all I had to do was run this and it would be the same exact shell. ls and cat flag.txt would give me the flag. Let's move on to the next challenge. The next challenge I'm going to solve is called patched shell. The description is okay, so you were smart enough to do Basic-Overflow, huh? Now try this challenge. I patched the shell function so it calls system instead of execve. So now your exploit shouldn't work. Bahahaha. Note, due to the copycat nature of this challenge, it suffers from the same bug that was in Basic-Overflow. See the cryptic message there for more information. So it's basically a part 2 for the Basic-Overflow challenge. We also have the same exact shell function except that it uses system instead of execve. So now why shouldn't our exploit work? Because shell is called using system and system requires the stack to be aligned, but execve doesn't care if the stack is aligned or not. Now it's very confusing what I mean by stack is aligned, but to align the stack you need to give it a ret or return gadget. So let me tell you more. For this I am going to copy my exploit from previous challenge, and this was our exploit. I'm going to uncomment this and comment that. Now we have our shell address, offset, payload, and yeah, we send it. Now what I'm going to do is change this to our current challenge, which is patched shell, and run this. And you can see we got segfault because, as I said, the stack is not aligned. Now to align the stack we need a ret gadget. Is a tool called drop gadget which helps us find gadgets in the binary, which in this case we need is a ret gadget. And here you can see a ret gadget. I'm going to copy the address, go here, pack. Again, every time we have an address, we need to use pack to send it to the binary, just like we used it on the shell function address. I'm going to save this. Now I'm going to run this. And as you can see, it worked and we got our flag.